all of you are saying, and then we should start here. Okay. So see, during last lecture, we were discussing about initially we discussed about the relationship between various elastic constants. So in that elastic constants, we have seen the relationship between E, mu, Z and K. So for that, E is Young's modulus, mu is Poisson's ratio, Z is shear modulus, and K, that is bulk modulus. Is it okay? So the various elastic constants, their relationships, and later on we started to discuss about the two things, out of which one was stress, whether it is scalar, vector or tensor. Is it okay? So three things we have seen: the concept of scalar, vector and tensor. Is it okay? Now my screen is visible.
Yes, sir.
स्क्रीन दिसते सगळ्यांना?
नाही सर.
जस्ट चेक वन्स अगेन. खाली काय करा, माझी स्क्रीन जिथं असेल त्याला पिन करा, म्हणजे ती स्क्रीन दिसेल. सी माय स्क्रीन इज विजिबल. स्क्रीन विजिबल आहे आहे ना? त्या स्क्रीनला पिन करा. सो जस्ट यू मेक पिन टू that screen so that it will be visible for you. Is it okay? Okay. See, so during last lecture we were discussing about this particular figure, and in that figure we discussed about three axes, out of which this one is x axis, this is y axis, this is z axis. So the stress along x axis, here we have given the notation. What is that notation? This particular notation, stress along x axis. What notation is used? काय notation वापरले त्याला? The notation used is sigma xx. Similarly, this particular stress along z axis, what is the notation used for the along z axis? Z axis चं notation काय वापरले आपण? Sigma zz. Similarly, the stress along y axis, we have used the notation here sigma yy. Is it okay? So sigma xx, sigma yy and sigma zz. So like this, three stresses are present here. Is it okay? Similarly, the stress component of x along z axis, here we have used this notation sigma zx. Then component of stress, x component of stress along y axis, we have used here notation sigma yx. So likewise, if we consider this particular surface only we are considering now this particular surface. एवढाच surface जर का आपण consider केला, then on that surface here we are getting three kind of stresses. Okay, we are getting three kind of stresses here. Which are these three kind of stresses? Sigma xx, sigma x, sigma zx and sigma yx. Is it okay? हा पर्टिक्युलर पॉइंट जर आपण इथं बघितला, हा एक जर सरफेस आपण इथं घेतला, so on that surface The three kind of stresses we are observing here, one of the component of force along x-axis, one of the component of force along y-axis, and one of the component of force along z-axis. The component of x along z, we have notation, we have used the notation sigma zx, and here notation sigma yx. Is it okay? So like this, on this particular surface, if we see this particular surface, then on that surface, whatever the components are acting, that three components we have taken into consideration. Similarly, on the opposite side of this surface, या surface बरोबर opposite side ला, is it okay? Along the opposite side of this surface, this is the opposite side of this surface. या surface बरोबर opposite side कुठले? ही side आहे, is it okay? On that side, if we take into consideration the various stresses, sigma xx, same equal and opposite kind of stress direction which is shown here, that as it is a tensile in nature, so pulling type of arrow is present, sigma xx. Similarly, equal and opposite to sigma zy, so sigma zy, so like this, and sigma yx. So here you can have this particular sigma xx, here you can see, then sigma yx you can see here, and similarly sigma zx that you can see here. So equal and opposite. So this particular component of force, if you take into consideration this particular component of force, so this is equal and opposite to this particular component. Okay. This component of force is equal and opposite in this direction. Similarly, this particular component of force which is shown here, equal and opposite kind of stress is present here, so that we can understand here each and every surface on that particular surface which is same parallel to this surface, and these are the stress systems which are present here. Similarly, if we take into consideration this particular surface, this is upper surface, and this is another surface which is present at the bottom side. Is it okay? So this is bottom and this is top surface. Is it okay? So top surface and bottom surface. On that, here you can understand the various stresses present. So this is one stress system present here and another stress system present here. Is it okay? So like this, we can understand initially the various stresses present here. Then let us have मागच्या लेक्चरला आपण याच्यावर डिस्कशन केलं होतं. So let us have this take into consideration this particular figure. So with this figure you will come to know that the point A is present here, point B is present here, point C is present here, and point D is present here. So A, B, C, D, these are the four corner points present here. So during last lecture we discussed about this, that suppose any component is present, and for that component small part we have taken into consideration. This is the small part we have taken into consideration, for which its thickness along x-axis we have considered to be on dx. Is it okay? So this dx is the small thickness along x-axis, and this is small thickness along y-axis. Is it okay? So see here dy and see here dx. So dx notation is used the small thickness along x-axis, and this particular dy, this notation is used the small thickness along y-axis. So AB is the small thickness along x-axis and BC is the small thickness along y-axis. So this small component is taken into the study. As a chota component, so this small component we have for the study here. Is it okay? So that we should understand here. Then let us see that for these things, suppose stress present at point A, we are considering sigma AA. If suppose the stress present at point B, we are considering sigma BB. Stress present at point C, we are considering sigma CC, and stress present at point D point, that is sigma DD. Then let us try to identify each and every stress. So first of all, let us start from this point A. So as far as concerned with this point A, now we will consider the stress present at point A as sigma XA or sigma XX. त्याला आपण नाव दिलंय sigma XX, the stress present at point A. So during last lecture we discussed about this one, that stress present at point A, stress present at point B, stress present at point C, and stress present at point D may be different due to the location of point A, B, C, D at different locations. There may be the different reasons due to which the stresses present at point these different points A, B, C, D may be different due to their locations. Is it okay? There are number of reasons due to which that stresses may be different. Is it okay? आपण मागच्या लेक्चर मध्ये याच्यावर डिस्कशन केलं. फॉर लास्ट लेक्चर वी डिस्कस्ड अबाउट इट. Okay. Now let us have the small look on that. The sigma XA is the stress present at point A, which we have considered as sigma XA is sigma XX. या A point ला असणारा जो स्ट्रेस आहे त्या स्ट्रेसला आपण काय अज्युम केलं? We have assumed the stress present at point A as sigma XA or sigma XX. Then stress present at point B we have considered sigma XB, stress present at point C sigma XC, and stress present at point D as sigma XD. हे 4 पॉइंटचे स्ट्रेसेस आहेत. हे स्ट्रेसेस आपण कन्सिडर करूया. Then this is the thickness dx and this is the small thickness dy. Is it okay? Along the y dy and along the x, that is dx. Is it okay? Then this is particular x direction, this is particular y direction. So these two directions we should understand, and accordingly now we have to see what is the stresses at point B, what is the stress at point C, what is the stress at point D. And for this analysis we are taking the reference as point A. So while calculating the stress present at point B, we should take the reference of A. While calculating the stress at point C, we should take the reference of point B likewise. Okay. So let us see here sigma XA, sigma XX. Then what could be the sigma XB? That is the stress present at point B. For that purpose, we will consider the reference point sigma XX as the stress present at point A, and then here these particular parameters dou sigma xx upon dou x dx, that is very important. That indicates that the differentiation of stress present at point A with reference to x and along dx. See, understand this particular point is very important. Sigma xb, while calculating this sigma xb, we are taking the reference of stress present at point A, and which is considered to be sigma xx. So sigma xb is sigma xx plus dou sigma xx upon dou x into dx. That means that the differentiation of the stress present at point A with reference to x only. Why we have taken this dou? Dou represents partial differentiation. And why we are taking partial differentiation? Because we are taking into consideration only x direction and we are not taking into consideration the y direction, because B point is exactly in the line of x direction of point A. A च्या रेफरन्सनी B point हा एक्झॅक्टली x डायरेक्शन मधून असल्यामुळे here we are taking only x into consideration and we are not taking y into consideration. So that becomes the partial differentiation. Because what happens that along this particular direction of x, so here with reference to A, B is have only one variable, and that is x variable. Is it okay? So here we should understand this thing. Okay, so let us have this sigma xb. Then while calculating this sigma xb, now we are taking the reference of sigma xx. So sigma xx is the stress at point A, and here differentiation of that sigma xx with reference to x and along this dx only. Is it okay? So that's why sigma xb is equal to sigma xx plus dou sigma xx upon dou x dx. So for that, we are considering this as equation number one. Is it okay? See here, this is equation number one, where we have written sigma xb, that is the stress at point B, which is equal to sigma xx plus dou sigma xx upon dou x dx. Now let us have the stress at point D. Let us consider the point D here. Where is the location of point D? So point D is exactly vertical. Point D is exactly vertical. So that's why here we will consider the partial differentiation only in the direction of y. Is it okay? Here we should consider the partial differentiation only in the direction of y. Is it okay? So with reference to A, D is vertically upward in the y direction only. So let us see what is the stress present at point D. Is it okay? So at point D, the stress present is sigma xd, which is considered to be sigma xx plus dou sigma xx upon dou y into dy. Is it okay? With reference to this sigma xx, here we are considering the differentiation of this sigma xx dou y into dy. So try to understand this particular step is very important. Initially, for identifying the stress at point B, we have taken the differentiation along the x, and in order to identify the stress at point D, we have taken the differentiation along y. So stress present at point D is equal to sigma xx plus dou sigma xx upon dou y into dy. Okay. Then let us now apply the same logic for identifying the stress at point C. Okay, so this is point C here. We can see here where is point C. C is present in this corner. And in order to identify the stress at point C, sigma xc is here, and sigma xc that can be identified with reference to the stress present at point B. So sigma xc is nothing but the stress present at point B sigma xb plus dou sigma xb upon dou y into dy. So we should understand this step also. This is very important step. See, sigma xc, so that is the stress present at point C with reference to sigma xb, means the stress present at point B in the vertical direction. So C point is present in the vertical direction of the B. So here we are considering only y direction, and x is considered to be constant in this direction. So that's why we are taking the partial differentiation at point C, and with reference to that, the stress present at point C is considered to be with reference to sigma xb dou sigma xb upon dou y into dy, because thickness is dy only. Is it okay? So let us understand this step. Equation number 3, what is the stress present at point C? Is it okay? Now we come to know now the stress present at point A, sigma xx. Now sigma xb is sigma xx plus dou sigma xx upon dou x dx. At point C, sigma xb plus dou sigma xb upon dou y into dy. And at point D, now dou sigma xx plus dou sigma xx upon dou y dy. So like this, at these four locations, the value of stress we have identified. Is it okay? Now, in order to identify exactly what is meant by sigma xc, let us substitute this value of sigma xb. So let us substitute this equation number 1 in equation 3. In equation 3, this term sigma xb. So we are substituting the value of equation 1, because sigma xb is sigma xs plus dou sigma xx upon dou x dx. So let us substitute this equation 1 in equation 3, so that sigma xc becomes equal to sigma xc is equal to, by replacing this sigma xb by this equation 1, sigma xx plus dou sigma xx upon dou x dx plus dou upon dou y. This sigma xb now has been substituted with this particular bracketed quantity sigma xx plus dou sigma xx upon dou x dx. Is it okay? And then it is simplified. So after simplification, after solving this thing here, uh, this particular term means after differentiating this, sigma xx remains as it is, dou sigma xx upon dou x dx as remain as it is, dou sigma xx upon dou y dy, and here dou sigma xx upon dou x after the partial differential second higher order term, it becomes dou 2 sigma xx upon dou x dou y dx dy. But as this particular thing is very small, is it okay? This thing is very small. Differentiation, partial differentiation, this particular stress is very small. This differentiation with reference to x, that is again small, because small component is taken into consideration. So that's why, and again it is higher order term. If for example जर आपण असं म्हणलं की 0.01, what is the square of 0.01, then that becomes 0.0001. 0.01, its square becomes 0.001. So that indicates that whenever we are taking the higher order terms, that becomes smaller. So this higher order term dou 2 sigma xx upon dou x dou y dx dy, as it is higher order term, that is neglected, so that is considered to be equal to 0 as shown here. Is it okay? So like this we should understand here. Then in order to calculate, now unbalance we have to calculate. What is the purpose? Now our purpose is to calculate the unbalance on this small component. This small component we have taken into consideration, and we have to identify the what is the unbalance. Then unbalance means what? If we identify what is the force acting on this surface, if we identify the force acting on this surface, if we take the difference, suppose this is positive x-axis, this is negative x-axis. If we take the difference between this positive x-axis and if we take the difference along this negative x-axis, then that particular difference we will consider as unbalance. Is it okay? So we are interested to find the unbalance acting on this selected small component. Is it okay? So this is small continuum, and for which dx and dy is the thickness along x and y direction. Then we are interested to identify the unbalance. आता आपल्याला याच्यामधला unbalance identify करायचा आहे. How should we identify this unbalance? Because the unbalance will be the stress present at point B plus stress present at point C divided by 2 into area of this particular, कारण स्ट्रेस आणि फोर्स यांच्यामधलं रिलेशन आपल्याला माहित आहे. In order to identify the force, we will have to multiply by area to the stress, because stress is equal to force upon area. So force will be calculated based on stress into area. Is it okay? So in order to identify the force acting on this BC surface, we will take the average of this B and C point. Is it okay? So stress present at point B plus stress present at point C divided by 2. Is it okay? Sigma xb plus sigma xc divided by 2 will be the average stress, and after multiplication of this particular surface area we will able to get the area. Is it okay? So after this multiplication of area we will get the force. So force acting in this direction. Is it okay? So in this direction, what is the force acting? In particular this direction, what is the force acting in this positive x-axis? Is it okay? Similarly, in order to have the force in negative x-axis in this opposite direction on this surface, now the surface points are point A and point D. Is it okay? So this particular surface AD surface So for that, we will have to take the average. So stress present at point A plus stress present at point D divided by 2. Is it okay? We will take the average stress acting on this surface. So sigma xx plus sigma xd divided by 2. So that will be the average stress acting on surface AD. Is it okay? So average stress acting on surface AD, so that will be influenced by these two stresses at point A and at point D only. Is it okay? So sigma xx plus sigma xd divided by 2 will be the average stress acting on this AD surface. Is it okay? Now, in order to identify the force, we will have to multiply by area. In order to identify the force, we will have to multiply by area, so that after multiplication of area, we will get the force acting in the direction of negative x-axis. Is it okay? So this is positive x-axis and this one is negative x-axis. Is it okay? So along this negative x-axis, we should take the average stress and we should multiply by area of this one. As BC thickness is dy or AD thickness is also dy, and this small component for which unit thickness we have considered, याची या पर्टिक्युलर सरफेसचा एरिया कॅल्क्युलेट करण्यासाठी याची थिकनेस किती कन्सिडर केली आहे, तर युनिट कन्सिडर केली आहे आपण. So that's why dy into 1, this will be the dy will be the area of that surface. Is it okay? So coming to this next slide, we will come to know the unbalance. Means now here we have discussed about this term, that sigma xc plus sigma xb divided by 2 into dy is the force on surface CB. Here you can see this force acting on this CB, that is force at point C, force at point B, its average, and by that way here we are considering sigma xb, sigma xc plus sigma xb divided by 2. So that will be the average stress into this particular area. So this becomes the force acting on surface CB. Is it okay? Similarly, now on opposite side, by considering point A and point D, suppose this is point A and this is point D, then average stress acting on this particular surface AD is sigma A, sigma xx plus sigma xd divided by 2 and this dy. So here you can understand this sigma xa plus sigma xd divided by 2 into dy. So that is the force acting in negative x direction. This is the force acting in positive x direction. This is the force acting in negative x direction. And that's why unbalance will be the difference between these two forces which are coming in positive x direction and negative x direction. So here you can understand sigma xc plus sigma xb divided by 2 into dy. So this is the force acting in negative x direction minus this bracketed quantity sigma xa plus sigma xd divided by 2 into dy. So that is the force acting in another direction. Is it okay? So here we should subtract this, and after subtracting we will get the exact value of these two direction of forces. One force is in negative x direction, another force is in positive x direction, and then subtracting that we will get 1/2 and this particular bracketed quantity. Is it okay? So are you getting this concept?
Yes, sir.
Are you getting this concept?
Yes, sir.
हे लक्षात येते का?
Yes, sir.
Okay, okay. So here by taking average of that, so by taking this average, sigma xc plus sigma xb divided by 2 into dy minus sigma xa plus sigma xd divided by 2 into dy, here we will come to know that 1/2 sigma xx So here see, you can see, so this particularly in terms negative and positive forces are subtracted from that, and after this subtraction we got the unbalance in this direction. Okay, so this is the unbalanced force in the x direction. So what is the unbalanced force in the x direction, Ganesh? Ganesh Chandane,
Yes, sir.
what is the unbalanced force in the x direction? एक्स डायरेक्शन मधलं फोर्स किती, एक्स डायरेक्शन मधला अनबॅलन्स फोर्स किती, अभिषेक गोडसे? अभिषेक गोडसे, हर्षवर्धन जोशी,
Sir, dou sigma x x divided by x into dx dy.
ओके, सो दॅट विल बी द अनबॅलन्स इन द एक्स डायरेक्शन. अभिषेक लक्ष आहे का? अभिषेक गोडसे लक्ष आहे का?
सर हॅलो,
हा, गणेश चांदणे
आवाज
लक्ष आहे?
डिस्कनेक्ट होत
माझ्याकडून काही डिस्टर्बन्स नाही आहे. सो ऑल अदर
नाही
स्टुडंट्स
सर,
आर.
इथं रेंज कमी
हा हा, ठीक आहे.
लॅग होते सर.
Yes, yes, sir.
गणेश, आर यू गेटिंग द थिंग्स? लक्षात येतंय का? लक्ष आहे का?
Oh, sir.
हा,
Yes, sir.
ठीक आहे. सो व्हॉट इज द अनबॅलन्स फोर्स
Yes.
इन द एक्स डायरेक्शन? एक्स डायरेक्शन अनबॅलन्स फोर्स किती आहे?
Mm,
डो सिग्मा एक्सेस
Dou x x y dou x dy.
Dou sigma x x upon dou x dx dy, that is the unbalanced
Dou
force in the x direction.
x dash.
Is it okay? Is it okay? हे लक्षात येते
Yes,
का?
sir.
येस सर.
So here same thing we can see here, that 2 sigma x x upon dou x dx dy is the unbalanced force in the direction of x. Is it okay? Now let us come to the next point of discussion. So that is the compatibility of plane stress or equilibrium in x direction. Is it okay? Now see this equilibrium in x direction. So here you will come to know that the equilibrium equation in the x direction for this particular 3D geometry. ही समोर फिगर समोर दिसते सगळ्यांना? आर यू गेटिंग दिस फिगर? Are you getting this particular
Yes, sir.
figure?
हो सर.
Yes.
Yes, sir.
Yes, sir.
Okay. So see, this particular x direction is shown here. Then y direction is shown here. Z direction is shown here. So this particular A, B, C, D, E, F, G, like this. Here you can see this point A is present. This point B is present. And this point C is present here. This point D. Similarly, point E, F, G, H. These are corner points which are present at different locations. Now, in previous figure, when we have seen the previous figure here, in that figure we have seen the different kind of stresses are present. Like this, you can see here the different kind of stresses are present. Is it okay? On that particular stress sigma axis, एका surface वर किती stress act होतात? How many stresses acts on each surface? एका सरफेस वर किती स्ट्रेसेस आपण कन्सिडर केलेले आहेत?
3.
हाऊ मेनी स्ट्रेसेस वी हॅव कन्सिडर्ड ऑन इच सरफेस? प्रत्येक सरफेसवर आपण किती स्ट्रेस कन्सिडर केले?
3 stress.
मनोज खरात?
3 सर, 3.
3 स्ट्रेसेस. Exactly. So that is correct one. So 3 stresses we have considered on each and every surface. Okay. Then see, now we are making the analysis only in x direction. Now we are making analysis only in x direction. आता आपण जे analysis करतोय ते analysis फक्त x direction लाच करतोय. Is it okay? लक्षात येतंय? So equilibrium equation only in x direction we are identifying, and that's why this particular surface EFGH, हा EFGH surface सगळ्यांच्या लक्षात येतोय. So you can see here this particular surface EFGH. Are you getting this surface EFGH? Are you observing this surface EFGH?
Yes, yes.
Okay.
Yes, sir.
Yes. So here the force stress acting. So that stress. Now we will take into consideration opposite surface also. The opposite surface जो आहे तो surface कुठला consider करतो? It's opposite surface we are considering here ABCD. हा surface लक्षात येतो ना? This particular surface you are getting ABCD. ABCD. This surface you are getting.
Yes, sir.
Yes. Okay. Now what is the opposite surface of ABCD? ABCD is opposite surface कुठला आहे? Surface EFGH is the opposite surface of surface ABCD. Is it okay? Surface ABCD and surface EFGH. Both surfaces are opposite to each other. Are you getting these two surfaces?
Yes, sir.
Yes, sir.
Then the stress acting on surface ABCD is sigma xx. Is it okay? Stress acting along this surface in the direction of x only. So we are considering here purposefully we have written equilibrium equation in x direction. Are you getting equilibrium equation in x direction? Is it okay? So that's why the stress acting on the surface ABCD is sigma xx, and then the stress opposite to this surface EFGH on that sigma xx plus dou sigma xx upon dou x. Now just to justify me why I have taken sigma xx on the surface ABCD and why I have taken sigma xx plus dou sigma xx upon dou x on surface EFGH. माझा प्रश्न लक्षात येतोय? Are you getting my question? On surface ABCD, I have taken sigma xx, but on surface EFGH, I have taken sigma xx plus dou sigma xx upon dou x. बरोबर का? असं घेतलंय का मी? Well, if I have taken, then why I have taken this? What can be the reason? असं घेतलंय तर का घेतलंय?
सर अलॉंग द विड्थ म्हणजे अलॉंग द एक्स डायरेक्शनला पार्शियल डिफरन्शियल करून त्यात म्हणजे ऍड केलं.
बरोबर. म्हणजे मगाचाच कन्सेप्ट आपण आता यूज केला. So last slide we have seen that what is the unbalanced force. इथं आपण unbalanced force काय हा कन्सेप्ट आपण इथं प्रूव्ह केलाय. So that is unbalanced force in the x direction. So sigma dou sigma xx upon dou x dx dy. So that is the unbalanced force. That concept we have proved, and that's why now we are taking into consideration sigma xx plus dou sigma xx upon dou x. Is it okay? हे लक्षात येतंय तुमच्या? हा surface sigma xx and dou sigma. Okay. Now see, so that particular thing was concerned with basically three stresses are present on this EFGH. EFGH वर जर आपण बघितलं तर 3 stresses act होतात. पण बाकीचे 2 स्ट्रेस आपण कन्सिडर केलेत का? Whether we have considered the remaining 2 stresses? या फिगर मध्ये जर आपण बघितलं, here we have 3 kind of stresses. इथं आपल्याला 3 stresses दिसतात. पण आपण कन्सिडर करताना इथं या फिगर मध्ये फॉर दिस फिगर ओनली वी कन्सिडर वन स्ट्रेस ओनली. एकच स्ट्रेस आपण कन्सिडर केला. का एकच स्ट्रेस आपण कन्सिडर करतो? व्हाय वी आर कन्सिडरिंग ओनली वन स्ट्रेस? Why we are considering only one stress? Because
We are checking for x direction.
because that the equilibrium equation only in x direction. X direction च equilibrium equation आपण बघतोय. So that's why this is the sigma xx plus dou sigma xx upon dou x. So that is the on this surface only. So this surface considered, this surface considered. Now remaining surfaces we will try to consider. Let us have AEHD, this top surface. Is it okay? So this particular top surface now we will take into consideration. हा जो टॉपचा सरफेस आहे हा सरफेस आता आपण कन्सिडर करूया. Is it okay? AEHD, the component of stress acting along AEHD. So basically if we consider this particular direction, then in this upward direction, we will get, is it okay? In this upward direction, we will get the sigma ZZ, is it okay? Because this is the Z axis. Because this is Z axis, we will get the sigma ZZ along vertical direction. However, the component of sigma ZZ along X direction, we have denoted it as sigma XZ. बरोबर का? Component of sigma ZZ along X direction, which will act on this surface, on this AEHD surface, will be sigma XZ plus dou sigma XZ upon dou Z. Is it correct? हा मुद्दा लक्षात येतोय का? सिग्मा एक्स झेड हे हा कन्सेप्ट लक्षात येतोय का? आर यू गेटिंग दिस सिग्मा एक्स झेड?
Yes, sir.
से येस, इफ नो से नो, नो प्रॉब्लेम.
सर परत एकदा.
हा, पुन्हा एकदा रिपीट करतो बघा. इज इट ओके? सो हियर इफ वी कन्सिडर, पुन्हा एकदा या फिगर कडे मी येतो. फॉर दिस फिगर बेसिकली sigma ZZ is the stress acting on Z axis. आणि मग या सिग्मा ZZ चा X डायरेक्शन मधला कॉम्पोनंट जो होता तो सिग्मा XZ होता. इज इट ओके? हा सरफेस जर आपण कन्सिडर केला, या सरफेस मध्ये द कॉम्पोनंट ऑफ सिग्मा ZZ along X direction we have considered a sigma XZ.
हो सर.
Is it okay? So now we are considering equilibrium equation only in X direction. So that's why we have considered only one stress and remaining stresses we are not considering because we want equilibrium equation only in X direction. Is it okay?
Oh, okay.
Okay. So sigma XZ plus dou sigma XZ upon dou Z. Is it okay? म्हणजे याच्या अपोजिट साइडला याच्या इक्वल आणि अपोजिट जर सरफेस जर आपण बघितला, दिस इज द टॉप सरफेस विच वी आर टेकिंग इनटू कन्सिडरेशन. सो AEHD, दिस इज द टॉप सरफेस अँड दिस इज पर्टिक्युलरली बॉटम सरफेस. हा जो सरफेस आहे हा बॉटमचा सरफेस आहे. इज इट ओके? आर यू कन्सिडरिंग दिस? आर यू गेटिंग दिस पर्टिक्युलर सरफेस बॉटम सरफेस? बॉटम सरफेस इज given with the points BF, this particular point GC. Is it okay? BFGC हा पॉइंट लक्षात येतोय आपल्या? हा सरफेस लक्षात येतोय? हा टॉपचा सरफेस, हा बॉटम सरफेस. ऑन दिस बॉटम सरफेस, so sigma XZ, now here you can see this particular direction and this particular force, sigma XZ, which is moving toward the left side, and this particular stress, so this force influenced by stress, so this is moving in the right direction. Is it okay? Once again, here the concept of unbalance we have used, and sigma XZ on the bottom surface with reference to this bottom surface. At the top surface, we have considered sigma XZ plus dou sigma XZ upon dou Z. Is it okay? Once again, the concept of unbalance we are using here. Are you getting concept of unbalance? Yes. Okay, very good. So here with reference to this sigma XX, initially we have used sigma XX plus dou sigma XX upon dou X. Now with reference to this surface, bottom surface, sigma XZ was present, and at the top surface we have considered sigma XZ plus dou sigma XZ upon dou Z at the top surface. And now remaining surfaces, out of which these two surfaces are remaining. कुठला surface राहिला आता? A, B, F, C, F, E, and this surface D, C, G, H. Is it okay? Are you getting now these two surfaces which are equal and opposite in front of each other?
Yes, sir.
So let us have the component of stress acting on this A, B, F, E. Is it okay? So initially, previously we refer the previous figure, then we will come to know that on these surfaces there were whatever the stresses, these three component of stresses were present, but only we are considering the component of force acting in the x direction only. So that's why along this surface CDGH, if sigma xy is present, then equal and opposite force of sigma xy, for that purpose sigma xy plus dou sigma xy upon dou y into dy by considering unbalance. Is it okay? So this is the sigma xy, the stress acting on this purpose, the component of stress acting in the x direction on surface CDHG, and equal and opposite surface is AB EFE, and on that whatever the component of surface, component of force which is acting here, which is shown as sigma xy plus dou sigma xy upon dou y into dy. हे लक्षात येत आहे? हे दोन कंपोनंट एकमेकाच्या समोरासमोर कंपोनंट लक्षात येत आहेत एक्स ऍक्सिस वरचे. Is it okay? So now,
Yes, sir.
in order to identify the equilibrium equation in the x direction, we will have to take the summation of all these forces. Is it okay? So as usual, we will consider that the sum of forces in positive x-axis minus sum of forces in negative x-axis. Is it okay? So for that purpose, now see, this is particularly the stress. But what is this dy dz? What is dy dz? What is the bracketed quantity and what is dy dz? Anybody? What is bracketed quantity and what is dy dz? So bracketed quantity is the stress and dy dz is the area. Is it okay? If we observe, if we refer this figure, dy is the thickness along y-axis. This is particular thickness along y-axis, and this is the thickness along z-axis. ही z-axis ची thickness आहे आणि ही जी thickness आहे ही thickness कशाची आहे? So this particular FG is the thickness along y-axis, and this is the thickness along z-axis. Is it okay? So that's why dy dz हा जो surface आहे, so for this particular surface if we take into consideration, हा जो EF चा जो surface आहे, हा surface जर आपण consider केला, then for this surface EFGH, what will be the area? EFGH या surface चा area काय असला पाहिजे? So for that, this is d
dy dz.
Yes, dy dz, and that's why here we have considered dy dz. This bracketed quantity represents the stress, and this dy dz represents area. Is it okay? When stress is multiplied by area, what will you get? Stress is multiplied by area. What we will get? Force. Is it okay? And that's why this is the equation of force. Is it okay? So here you can see this sigma xx plus dou sigma xx upon dou x dx minus sigma xx. So what is this particular quantity? We can understand this quantity sigma xx plus dou sigma xx upon dou x dx is the stress by considering unbalance, and this sigma xx is the reference surface, the stress present on the reference surface. Sigma xx is the reference surface, and this particular surface on which we have considered the unbalance also. So dou sigma xx upon dou x is the unbalance present. Is it okay? So this is the stress difference. This bracketed quantity represent the stress difference. Sigma xx plus dou sigma xx upon dou x dx minus sigma xx is the stress difference, and that stress difference is multiplied by area dy dz. So after this multiplication, we will get the unbalanced force acting on this surface. Is it okay? Along x direction. X direction मध्ये या दोन surface वर act होणार unbalanced force. So that force will be given by this particular quantity. Is it okay?
Yes, sir.
Similarly, now if we consider the surfaces, now see here, so sigma xy. If we consider the sigma xy, this particular surface, here we can have this surface. हा surface इथं आहे आणि या surface वर जर आपण बघितलं, sigma xy हा surface टॉपचा आहे, हा sigma xy plus dou sigma xy upon आणि dou x हा बॉटमचा सरफेस आहे. So if we subtract the positive x-axis is sigma xy plus dou sigma xy upon dou y dy, and this sigma xy is in the opposite direction. So that's why we should take the difference of that. So sigma xy plus dou sigma xy upon dou y dy minus sigma x, and for that we have multiplied by dx dz. So here with reference to this surface dx, we know that the thickness along x-axis and this particular dz, that also we know. So by considering this difference, we have identified the unbalance on that surface along x-axis, and this particular third bracket, we can understand here that this is the stress difference in the bracketed quantity on remaining two surfaces, and here dx dy represents the area. And then in order to identify the unbalance, the positive x-axis force minus negative x-axis force plus one more factor is added here. Is it okay? See here, this one more factor is capital X dx dy dz. So capital X represent the body forces. Remaining all kind of forces which are shown in this figure are the surface forces. So two kind of forces acts on any body, out of which one is the surface force and another is body force. There is a difference between surface force and body force. The surface force is the traction, and body force is the total force acting on whole body. Suppose magnetic force that acts on the body, gravitational force that acts on the body, hydrostatic force that acts on the body. But when surface is influenced, if traction is applied, then that traction gets applied on the surfaces. Is it okay? So that's why this sigma xx and this sigma xx plus dou sigma xx dx. So like this, these forces are on the surfaces. So all these forces which is shown here, is it okay? So all these forces, this is the part of surface force, and this particular force capital X dx dy dz, that is the acting on total body. So that's why we have considered that body force acting along this particular continuum which we have taken for study. For this we have multiplied by dx dy dz, and that's why capital X into dx dy dz. So that is the total volume, and dx dy dz is multiplied because x is considered to be force acting on total body, that is acting on total volume. So that's why we have multiplied by dx dy dz. Okay. But as this particular figure is in equilibrium, that is steady, so that's why this total part we have considered equal to 0. Okay. Here we have considered that total part as equal to 0. That indicates that unbalance is 0. Is it okay? If that particular figure, that particular continuum, that particular selected part, if it is steady, if it is in equilibrium, then definitely that total forces or summation of all these forces is equal to 0. And then by cancelling the terms, finally we got here equation. If we simplify this, then after simplification we got here the equation is that dou sigma xx upon dou x plus dou sigma xy upon dou y plus dou sigma xz upon dou z plus capital X, which is body force, is equal to 0, which is considered to be equilibrium equation. Is it okay? Are you getting equilibrium equation? Are you getting the concept of equilibrium equation along x-axis?
Yes, sir. Yes.
Yes, sir.
So dou sigma xx upon dou x plus dou sigma xy upon dou y plus dou sigma xz upon dou z plus capital X is the body force is equal to 0, is considered to be the equilibrium equation in the x direction. The equilibrium equation or the compatibility equation of the stresses. Here one more notation, here one more stress compatibility equation of stress or equilibrium equation of stress, that is considered as this bracketed quantity. Similarly, if I try to identify equilibrium equation along y-axis, then that becomes dou sigma yx upon dou x plus dou sigma upon dou y plus dou sigma yz upon dou z plus capital Y is equal to 0. and dou sigma zx upon dou x, dou sigma zy upon dou y plus dou sigma zz upon dou z plus capital Z is equal to 0, which are the similar equations like that of equilibrium equation along y-axis and equilibrium equation along z-axis. Is it okay?
Yes,
Have
sir.
you understood this? हे लक्षात आलं का?
Yes, yes.
Yes, sir.
Okay. So, shall we stop with this concept here? Any doubts?
No, sir. No.
Any doubts?
No, sir.
No, sir.
If there are any